Hi everybody, today we're going to have a look at arithmetic sequences and how that applies to our linear algebra. So to start with, we're going to look at some number sequences, and two in particular, the even and odd number sequence. They're both arithmetic sequences because they increase by a constant. So each consecutive number increases by 2. So in the even numbers it goes 2, 4, 6, 8, 10, and in the odd number sequence it goes 1, 3, 5, 7, 9, 11. The only real difference between them is one starts at 1 and the other starts at 2. So a bit of naming conventions. The third term in the positive even number sequence, so here's the even number sequence. The third term T3 would be 1, 2, 3 would be 6. The fifth term T5 in the positive odd number sequence, so here's the odd number sequence. And the fifth term 1, 2, 3, 4, 5, T5 is equal to 9. Now we're going to use those later. So once we have these two lists of even numbers and odd numbers, we can put them into a table. Here is our table here. So the even numbers, at the top here we've listed the position in the sequence. First position, second position, third position, fourth position, fifth position, sixth position. And the term itself, 2, 4, 6, 8, 10, 12. So T1 would be 2, T2 would be 4, T3 would be 6, so on and so forth. Now we can list these pairs of numbers as coordinates. So this becomes 1, 2, 2, 4, 3, 6, 4, 8, 5, 10, so on and so forth, as the even number sequence. And we can also, instead of listing it, as we did up here, here's the odd number sequence, we can list that in a table. Here's the positions, first position, second position, third position, fourth position. Let's erase that off again. And here are the terms. So 1, 3, 5, 7, 9, 11, the numbers that you're familiar with regards to odd numbers. Now, what we should note is the term in front subtract the term behind always equals 2. So 3 take 1 is 2, 4 take 2 is 2, and we can list that like this. The term in front subtract the current term is equal to 2. Looks fancy, doesn't mean a lot. So let's continue. Now where the position in the sequence increments by 1, so this is the position in the sequences here, and we can see here this goes up by 1 each time, we call this a difference table. And a specific feature of a difference table is that the differences have meaning. If this doesn't increment by 1, then we can't really look at these differences to give us a meaning in the same way. So here's our difference table for even numbers, and if we look at the differences between the terms, we can see that it's constant. And in any arithmetic sequence, we'd expect this to be constant. If it wasn't constant, it's not an arithmetic sequence. And in this case, the difference is 2. So if we plot this on the graph, we can see that for every one that we go across, the term increases by 2. For every one that we go across, the term itself increases by 2. So here is 1, 2, here is 2, 4, 3, 6, 4, 8, so on and so forth. And when we graph an arithmetic sequence, any arithmetic sequence, we will find that it forms a line. We do have to be a little bit careful in interpreting it though, because if we look at this line, one valid point on it would be 5.511, which isn't an even number. So when we interpret future values using this line, we'd have to be careful only to look at whole number values for x, or else we won't get an even number, we'll get something else. So in the same way, if we're given a line, any line, and we convert points on the line that are 1 unit apart, we will get a constant first difference when we put it into a difference table. So if we had 1, 1, 2, 3, 3, 5, took them off the graph of any line, put them into a difference table, we would find that the first difference is always constant. Well, there we go. There we have looking at lists of sequence as a list, sequence in a table, sequence in a difference table plotted in a graph, and then looking at lines in a graph and putting them back into a table and seeing that the difference is constant. I hope that was helpful, and we'll look at that with some a bit more detail in the next one. Thank you, everybody.